Thanks so much for making time for this webinar. We would like to start very quick. Okay. So today we have in our midst Gilbert Adjei, who is going to talk about deploying models and setting up CD and CI pipelines for ML applications. So I would like to talk a little about who Gilbert Adjei is. So Gilbert is a professional data scientist who also doubles as a software engineer at Superfluid Labs. He's an intense passion. He has an intense passion in using AI to solve socio-economic challenges in Africa. Yeah, he has authored myriad publications and has been an avid speaker at both local and international AI conferences. So, hi Gilbert.
Hello, Debbie.
Yeah, I'd like to give the floor to you. You can start now.
Thank you very much, Debbie,
Welcome.
for the introduction. Hello, everyone. Once again, my name is Gilbert Adjei, and I'm very much excited to speak on this topic, deploying models and setting up CI/CD pipeline for machine learning applications. So, as rightly mentioned, I work with Superfluid Labs as a data scientist and a software engineer. And I've been involved in AI projects and AI conferences like Debbie mentioned. So let's delve straight into the agenda for today. So today's outline is going to be about, we're going to have an introduction, and we're going to see the reason why we should deploy models, the importance of the model deployment. We are also going to touch on continuous integration, delve in why it's important, and continuous delivery. And we are also going to look at various CI tools that exist. And at the end of the day, we are going to have a practical session. Okay, so it's not only going to be about slides and then theory, but we are also going to experience hands-on practicals. Okay, and when there is time, we'll just also touch on some bonus points that I have for today's participants. So one will be asking him or herself, why would you want to deploy a model? Why is it necessary at all for you to deploy a model? So to answer that, my answer to such a
Finish
question
your
is
yoga.
my answer to such a question is simple, so that everyone can use it. That's the basic answer that I can give to why you would want to deploy a model. So you can have a project whereby you detect diseases in plants or even health diseases in some parts of organs of human beings, or even you would want to predict the probability that a person is going to pay back a loan or something like that. But then at the end of the day, you don't want the analysis that you built sticking in your own machine, right? You would want it to be accessible by everyone. You would want to drive economic opportunities. You would want everyone to benefit from the hard work that you've done. So that's the reason why you would want to deploy a model, so that it is accessible by everyone. Now, like I mentioned earlier on, we have a couple of use cases where machine learning is applicable. So I mentioned detecting diseases in plants, detecting diseases in human organs, even predicting loans. And we can even see a lot. This list is not even exhaustive. We have many applications of machine learning. And all these applications that we have don't have models sitting on individuals' local hosts. They have their models deployed. So if you want automatic translation, you don't have your model sitting in one person's computer, but then you have a model being hosted somewhere, and then it's being fed by data for the automatic translation to be done. Now, when we talk about continuous integration, what does it mean? So continuous integration basically is the ability to consistently, and the key word over here is frequently, integrate code together. Okay, so we have a number of tools like GitHub that allows individuals to contribute code, put code together, push code together, and work on a project together. So that's a tool that falls under continuous integration. And the key aspect of continuous integration is you having the ability to automate your testing. Okay, so it's not the idea that you just push your code, another person will push your code to a common repository, and that will be it. But then, what if you are working on one aspect of a code, you push your code, and then it breaks the entire project? So continuous integration allows you to test your code, and when it is successful, it is integrated or it is being merged to the whole project. Now, what about continuous delivery? When we say continuous delivery, what is it about? So continuous delivery also is the ability to consistently make incremental delivery to a web application. Okay, so we can have a big project, and then we have clients always on your neck to produce or develop new features. So what usually happened in the past was that developers or software engineers or even data scientists would wait and then finish all their work before it's being presented to the client or to the user. But then with continuous delivery, you can consistently make incremental deliveries to your client without waiting to complete everything before you show it to your client. So that's the general idea of continuous integration and continuous delivery. And you hear it very often. Either you hear continuous integration, continuous delivery, or the shortened version, which is CI/CD. Great. So what are some of the CI tools that exist? So what are some of the continuous integration tools that exist? So we have a number, quite a number. This list isn't exhaustive. We have Travis, we have Jenkins, we have Circle CI. And for this tutorial or for this presentation, we are going to use Travis CI as our CI tool. Travis is free. It started in 2011. It was open source and then later on commercialized. So this CI tool allows software engineers, data scientists, and many other project managers to even maintain quality in collaboration. So that is it about the CI tools like Travis. Now, how does it work? So it works in this way. So usually we have developers, we have software engineers, we have project managers, we have data scientists, we have machine learning engineers, all pushing their code to a common repository like GitHub. Okay. So, and then another person will pull and then make the changes and push back. So how this CI tool works is that when you push your code to GitHub, GitHub will notify Travis, okay? And it does so by using what we call webhooks. And Travis will be notified, and then Travis will pull the code from GitHub and then run tests. And when these tests pass, they get, in our case, deployed to a server. Okay, so at the end of this session, we are going to build an end-to-end data science product. Okay, so we are going to build an application that is being powered by a model. And we are going to include all that we've talked about over here. So that's the brief summary of what we are going to do. Now let's delve into the hands-on session or the practical session. So like I mentioned earlier on, we are going to build an end-to-end data science product that's within this short time, okay, within this short time frame. And we are going to start, as we all know, we begin by understanding the problem that we want to solve, and then we collect data, do cleaning, and so on and so forth. And at the end of the day, this will be the end product. So it's going to be a simple application that is being powered by AI. So if we say maybe we predict Jesus is Lord and click submit, Heroku is a bit slow, but what we want to see at the end of the day is the prediction of what we typed in here, and what we typed in here as a test is going to be fed into a model, and then a prediction is going to be generated. So from data collection up to this point where we deploy the model and use the model in production. Okay, so let's get started. As usual, many data scientists, 90% or 95% use this Jupyter notebook, which is very great tool for prototyping and then for analysis. And the data set that we are going to use is the fetch 20 news groups. Okay, so this data set presents about 18,000 news groups and with 20 different categories. So, and it's freely available from scikit-learn. You can just import them, this data set from sklearn, and it will automatically be downloaded. Okay, I have already worked on it and downloaded it. And one thing that you would want to do in your journey or even as a professional is to see how best to optimize your code. Okay, so this particular data set always you would have to download it over and over and over again. So in order to save yourself some bandwidth, so I don't want to be downloading 40 megabytes every time I want to use this data set. So what I did was to use module Pickle to save this data set on my disk so that I can easily load it whenever I want to use it. I don't want to be downloading this over and over and over again. But if you are starting it, you would first have to download it. But subsequently, you can pickle this data set and then be using it. So as we can see over here, I'm loading the text portion of the news post and storing it in the variable news underscore text. And then also loading the train set and storing it in the variable news underscore train. So I'm going to build a model for this particular data set. And before I even do that, know that we would have to first of all transform this data set that we have. First have to do a lot of cleaning and then some transformations before you can even make predictions on these data sets. So over here, we in cell 5, I'm importing the count vectorizer, and what the count vectorizer basically do, what it does is to assign unique numbers to each element in the text, and then also count the number of occurrences, say, within a text. And one of the pitfalls of count vectorizer is that common words like the, which we refer to them as stop words, it assigns a number of great counts to them. So one way to do away with such a pitfall is to remove the stop words, or you can use also, and in addition, you can also use the TF-IDF transformer. So TF-IDF, what it basically does also is to pick the result from the count vectorizer and assign weight to this test. Right. Now let's continue. So that has been done in cell 5, and the transformations have been done. And after the transformations have been done, we are going to use a naive Bayes as our classifier. Always, you would want to start with a baseline model before you use a more advanced algorithm or model. Okay, so you don't always start with, depending on the use case, you don't always start with very advanced, like maybe RNN, go with TensorFlow used by Torch without any understanding of a baseline model. So you always would want to start with a baseline model, check the performance. And if it requires something which is more advanced, or like TensorFlow, heavyweights like PyTorch, then why not? And of course, you always would want to use the right tool for the right job. When you are predicting an image, you don't want to be using scikit-learn, of course. So you always would want to start with something which is simple and check the performance and build on it. So we are starting with naive Bayes. And naive Bayes, as we know, before we even talk about naive Bayes, probably we can do a refresher of the Bayesian methods and how it works. So the Bayesian methods basically are methods of statistical inference that establishes the fact that an individual's prior beliefs about an event may be changed given the presence of new evidence. Okay, so and naive Bayes, how it works is given a set of features. It asks the question, given a set of features, which class does a measurement belong to? So does it belong to class 1, class 2, class 3? So in our case, does it belong to atheism? Does it belong to Christianity? Does it belong to politics? Does it belong to graphics? Or does it belong to science? So, and it's called naive Bayes. The word naive because it assumes that the features are independent, but in the real world, it's never the same. It's never true. So, but this is a very controversial topic. But naive Bayes, because of its simplicity, it's very, very fast and it's also very scalable. So that's why we are using it as our baseline model. So over here in line 6, we are fitting the data and we are going to make predictions on the data. So over here, we are doing that for line 7 to line 8. Line 8, we are seeing the predictions, which returns an array 2, 3, 4, and it corresponds to the target name. So if you want to see the target names, as we know, arrays always start from 0. So atheism is 0, graphics is 1, science.med is 2, and so on and so forth. So this line 7, what I presented, Tesla is worth billions, is being predicted as a 2. So it's being predicted as 0, 1, 2. So it's being predicted as this, which isn't true, right? And Moses parted the Red Sea. It's being predicted as a 3. So 0, 1, 2, 3. It's being predicted as something that belongs to Christianity. Trump is the best president of US. It's being predicted as something which belongs to politics. Okay, so the accuracy of this model, simple model that we built, is around 80%. So 79, yeah, around 80%. And yeah, we are going to assume that we are happy with it. But then what you would want to do is to go back and tune some hyperparameters or do some further cleaning or some transformations on it. But for our purpose of this session, which is deploying the model, we've had the data being collected, doing some basic transformations, and then we are now going to deploy this model. We are assuming that we are happy with this model. So over here in cell 13, what I'm doing is just mapping the indices of the target to, so the index and then its target, the index and the target. The reason why I'm doing that is because when you want to take this model into production, it will come in handy. So we dump the model over here in cell 13. So usually you don't want to end your data science journey in a Jupyter notebook. You would want to take it a step further. So now that we've done our modeling and data cleaning up to the model, a stage where we've dumped the model, let's use it in a Python file. So usually what you would want to do is not to stick with Jupyter Notebook, but then to take model into production, you would want to write in Python file. And we are going to wrap this model using Flask. Okay, so Flask is a micro framework, Python micro framework that allows you to easily build APIs and simple web applications. Okay, so we do of course, we have to define our requirements in the file called text.txt. So in this simple application that we are going to build, we have to define all the requirements that we are going to need in order to deploy our application. And since we are using scikit-learn, we have to import them, import pandas, Flask, gunicorn, gevents, and then pytest. So if you are using a different framework, you also do the same thing, or library like TensorFlow or PyTorch or H2O or any other machine learning library or framework. You do that accordingly. Now, once you define your project dependencies, like I mentioned, we are using Flask to build this simple application. So over here, what we are doing is we are importing all the necessary libraries and modules from line 1 to line 8. And Flask is very easy. So what you have to do is just declare, that's the line 13 is, we over here, we are using at app. So this is a decorator, a Python decorator. And then we are saying that this is the index route. So anytime you see a hash, I say hash, slash, that means it's the index. Okay. So over here in line 15, what I've done is to create an index.html file. So this is how it looks. So cd knife base ls yeah, wait. I want to get out of excuse me, cd app ls. Okay, so always you would want to have your application running in a virtual environment, okay, so that your dependencies are isolated. You don't mix up with other dependencies on your local machine. So over here, I just enabled my virtual environment, and if I want to start the application in Flask, all that you need to do is just call like here. And now you can see that the application has started, and you can access it on this localhost 5000. So you can see that my Flask application has started and it's running on the port 5000. So without anything, without any slash, you are saying that this should be your home page. Okay, so that is it's for line 13 to 15. And this index.html file is what we are seeing over there. So we put the index.html file in a folder called templates. And over here, it's just some basic HTML with a button. And then I also wrote some basic JavaScript to disable the button when a person hasn't entered anything. And this is something that you would want to do because you don't want a person to submit an empty string to your model and then be demanding predictions, right? So these are front-end things that you would want to do. And from 48 to 55 is also just something very basic, which after a person has clicked on submit, it just show the submit pop-up. Okay, so assuming I type in the COVID patient has recovered, and I click. So this thing that you see over here, okay, the submitted pop-up is what is being triggered from line 48 to 55. And so that is it with the basic HTML file. And now, what we would want to do is that after a person submits the text, we would want to take what the person entered, and then we are also loading in the file that we save to disk, as well as the model that we save to disk. And then what we are going to do is to transform what the user entered, that is from 28 to 34, and then we make predictions. So the prediction is the model that we built in the Jupyter notebook. We load it and then we make predictions, and then we submit it as, we return it as a JSON response. So that is it with the HTML and then the prediction part. So like I mentioned, this will come in handy because when you make predictions in scikit-learn, it returned an array. So either 0, 1, 2, 3, or 4. So what we needed to do was to create a map such that if a person was predicted to be 0, it will be mapped to atheism. If it was predicted to be 1, computer graphics, and so on and so forth. So that was why we created this map. Now, how does CI/CD fit into this? So the thing is, yes, it's great. We've created this application which is being powered by the naive Bayes model. How then do we take this model to production so that everyone can have access to it? Everyone can be making predictions to it. Okay, so if we remember, we talked about the idea of continuous integration and automatic testing. Okay, so what you would want to do is that when you push this application that you've built to a centralized repository like GitHub, you'd want to run some tests. And if it passes the tests, then you push the code to a live server. Okay, so you passing the test falls under the CI, and then you pushing your code automatically or incrementally falls under the CD, which is the continuous delivery. So over here, we've defined a basic test, okay, that's say that it should test whether there's an access statement. This is 1 plus 2 is equal to 3. So there's a basic test that we wrote for our application. But in the industry, you would want to write a more comprehensive test to test your application, right? And if it passes the test, then you push the code to the server, either AWS or Contable, or in our case, we are using a free server, which is Heroku. Okay, so that is it with the test file. So how do we set up Travis, the CI tool that we are going to use for our application? So you go to travis.org. So you can see that. So when you visit travis.org, you have to log in, and then what you need to do is to link your account to your repository. Okay, So in this case, the repository, I'm using my GitHub repository, and what I did was to creating an account on Travis's. I mean, it's just like any normal application, signing up and then linking to your repository that you would want to run some tests on. And once that is done, it's just by using some few clicks, entering your credentials and then linking to your repository. You would see that anytime you push your code, what it will do is you need to define what we call a .travis.yaml file. And this travis.yaml file is a configuration file, okay? So it's a configuration file that defines what needs to happen when you push your code to GitHub and Travis receives your code. So in our case, what we wanted to do is that the configuration file, which is a key value pair, as you can see over here, we are defining the language that we want to use, which is Python, the distribution, and then over here on line 3, I'm saying that before you do any installation, just cd into this application and this folder, sorry, and when you are in this particular directory, run this command, which is pip install requirement.txt. So what it's saying is that after you are, or when you are in this directory, go through requirement.txt and then install all the dependencies. Again, requirement.txt is this one. So it will go through each line and then install all the dependencies, okay? And then what file should it run as your test? So in this case, we are saying that we are using PyTest. So anything that has test underscore, it should run it as your test file. And when it passes, you should deploy it to a server, which is Heroku in our case. So you specify provider Heroku over here, and then you go to, but before you even specify over here, it means you need to create an account on Heroku. So that one too is also quite straightforward. Visit Heroku and then you also sign up over there. So Heroku is great because it's free for small applications. And once you log in with your credentials, you have the ability to create apps, okay? So the name of the application that I'm going to deploy over here is called Naive Base Flask App. So I just created that, and under deploy section, okay? So under deploy section, what you would want to do is under deployment method, you select GitHub, okay? Because our code is being hosted on GitHub, and then you choose the repository that you would want to be listening to. So over here, we are using the Naive Base repo that we created, okay? And this is the most crucial aspect of it. You should always ensure that you click wait for CI to pass. So in that case, what you are saying is that when the test that has been defined in your Travis path and continue. So what you would want to do is to make sure that this checkbox is clicked so that when it passes the CI, it's automatically deployed to Heroku.
You are hacker. You are hacker.
Hello?
Yeah, Gilbert.
Yeah. Okay.
Yeah, please continue.
And once you set up this and everything is okay, you just have to push your code. Okay. So you, over here on line 13, we have the naive base app. Specify the app over here, and you also get the API key and then place them over here. So basically, that is all that you need. And you need one last thing that you need is the proc file. So proc file is what tells Heroku what to do, the application or yeah, the application to run. And inside this proc file, we are saying that we should use the JUnocon as the HTTP server because Flask by default doesn't have, or its server does not scale in production. So you'd want to use something more advanced like Nginx or and JUnocon, or in our case, we are just using JUnocon. So we specify that in the proc file, and then we just push the code to GitHub. Okay, so let's do an example, one example, and then we can take some questions from the participants. So let's see how this works. So instead of send, I'm changing it to submit. Okay, and let's see how that will work out. So claim and do let's let me check the files that I changed. Okay, so git add templates / index.html, and then let me comment git message is changed to submit button. So that has been done, and now git push. I enter my credentials. Adjei, and okay. So you can see that it's being pushed, right? So automatically, we should see it reflect over here. So let's just give it some few seconds. So you can see the commit has been received, changed to submit button. And then Travis will begin the building process. Okay, so it will first of all go through the configuration which we defined in the .travis.yaml file, and then clone it from the GitHub, my GitHub account. As you can see, it just cd'd into this, and then it's installing the requirements that I specified in the requirement.txt, and it's passed the test. So it means that it's going to push it to the live server. So you can see that it's showing installing deploy dependencies. The authentication has been successful. And right now it's trying to upload or deploy to the server. So you can see the build process over here. So triggering new deployment, and this should take some few seconds. And you can see how helpful this is. So you don't have to be always logging into your server and then pushing code there. Once you set up a CI/CD pipeline and you push your code to GitHub, it will automatically run the test that you've defined and then deploy them automatically to the server, which in our case is Heroku. Now, this CI/CD idea is being employed by almost all open source projects. So if you want to contribute to scikit-learn or PyTorch or TensorFlow, it employs the same idea where when you fork the repo, you make changes, you push, it will run the tests, and only when the test pass before your changes will be merged in a way to the repo. So you can see that it has successfully pushed to the server. And anytime you see an exit code of 0, it means that it was successful. And you see anything apart from 0, it means that there was a problem. So now all that we needed to do was to push to GitHub, right? Now let's see whether that has reflected on our application. So when we visit the live application, you can see that it has been changed from send to submit. So thank you very much for your attention, and I'm willing to accept any questions from the audience and the participants.
Hi, Gilbert. Thank you very
Hi.
much for the presentation. Deborah is having issues and is taking over now. So, okay. Deborah, Gilbert is done with the presentation, so you can go ahead.
Hello, Gilbert.
Hello.
Thanks so much for a wonderful presentation, and we are very sorry about what happened. Okay. Please, you can ask questions. Our guest speaker is available to answer all your questions, and you can also type it in the chat section if you don't want to speak. Please, I have a question.
Yeah.
Okay.
Hello, Gilbert.
Hello.
Yeah, please, may I know what are the needed skills from the start to the end? What are the various skills that you need to be able to do this?
Okay, that's a very great question. Thanks for that. So probably starting, you need to have some understanding of Python, and of course, you know that if you want to do machine learning or AI, we have many tools to do that. Either you go by R, Python, JavaScript, whatsoever. So you choose a tool that you are comfortable with, and then you master it. So in our case, we are using Python. So I would speak from that point of view that you start from Python, and if you want to build a model, definitely we have different libraries and different frameworks. So we have scikit-learn, we have TensorFlow, PyTorch, and so on and so forth. So again, you choose the one that you'll be comfortable with, you master it, and you solve a problem with it. So the basic skill that you need is your ability to solve problems. So that's and the thing is, where there's a will, there's a way. So once you have the will to learn or improve, you can just pick a tool and then use it and master it. So you start from Python, go to maybe statistics. We did some statistics over here, scikit-learn, and then know some small HTML, CSS. It's not compulsory though, but you need to be curious. How do I do this? And then Google is always your friend. You Google it, you learn along. So that's the skill that you need. Your ability to be curious and also having that problem solving acumen. So that's what you need to have.
Okay. Okay, so
Yeah, there's a question here.
Okay.
Um, that hello. So you used fit transform for X-train, but you used transform for X-test. What is the reason for doing that?
Okay. So usually when you've already fit, when you are training, you have already fit. So fitting in, I would say in its simplest definition means learn the relationship within this, so that at the end of the day, when I show you a test, you can just transform on it. So we usually do a fit on the training set, but then on the test set, we just use a transform. So that's the reason why.
Someone also asked whether we are getting the recordings after. Yes, please. The video, the slides, the codes will be made available. I think Gilbert has it on his GitHub repository, and he's even writing an article on Medium about it. So everything will be available after
Yeah.
this. Um, okay, I think these are the questions here for now.
I
So
have a
Deborah, you
question.
can.
I think so.
I have a
Hello,
question.
Yvette.
Yeah.
Hey.
Hi. Thank you for the tutorial. It's very helpful. I have a question. I saw that you deactivated Conda and then you went into like a virtual environment. My question is, what's the difference between the Conda and then the virtual environment? And
Okay.
then I have another question as well. What's the difference between G Unicorn and Hiroko?
Okay. Thanks for that.
Thank you.
So, so before I even answer that, Yvette is my colleague at Data Science, Superfluid Labs, and John also is my colleague. I don't know whether other colleagues of mine are here with us. So hello to you all, fellow Superfluid Labs colleagues. Okay, so the first question is the Conda and then the virtual environment. So over here, because where is it? Over here, yeah. So I needed to, in a way, get into the my virtual environment because that was where I had installed my dependencies. My dependencies they weren't installed in the Conda environment. I had installed it in the virtual environment. So I needed to create or activate the virtual environment and get into it. But then if I was to be having it over here, I would have used it straight away. But usually it's best practice to create your separate virtual environment and then install your dependencies over there. And with the second question, which is the difference between G Unicorn and then Heroku. So Heroku is more like a platform where you can host simple applications, lightweight applications. And G Unicorn is more like an HTTP server. So anytime you make a request, before it hits any of the endpoint to access these resources, we are saying that we should use G Unicorn for that. So that's the difference between the two.
Okay, thank you. He's just one more follow-up.
Okay.
So does it mean that you can actually create a virtual environment in Conda and then use it straight away?
Yeah, it's something that you can do.
Okay. Thank you.
So,
Okay. Thank you very much, Yvette. Our host is having issues, so I'm gonna just continue to ask some questions. We have a question here. What modifications do I need to the Pickle file in order to use my model, say in Java also? And how is the step of CI/CD differs? How does it differ from the traditional software application?
Okay, so by the first question, which is you pickling it and then using it in Java, I believe there are great resources on that. And this is not only limited to Python language. So yeah, you can do the same thing for Java and any other programming language. And there are awesome resources available online for that. And I don't think I'm so clear about the second question, which is what's the difference between the traditional software application and CI/CD? Was that it?
Yes, please, that was it.
Yeah, I'm not so clear about it, the question. So if you can.
Sorry, can you hear me?
Yes, I can hear you.
I wanted to mean like we are deploying machine learning and how could it be different from the traditional software with the program which is on machine learning based? The steps we are using here, are they different or they are the same steps?
Oh, they are the same steps. So the idea is the same. You have what you usually have is to, of course, have your server. Either you have AWS as the server or Heroku in this case as the server or Contabo, any other server. You have the server setup over there, and then you use the Travis, also the setup. So over here, the deploy, where we have provider, you specify where your server is, and then basically that should be it. And then you specify the GitHub repo, which contains your project. So the idea is the same. It's not limited to only machine learning applications.
Okay. Maybe my next question would be, would it be better maybe if I separate my model from the application instead of having them together?
Can you
maybe
please?
for the reason of maybe making updates or something. Anyway, it's clear.
Please, you are breaking. Can you repeat that again, or if you can?
Okay, my question is, let's say I need to update my model.
You have to upload your model.
Yeah, it's already in production right now.
It's already in production.
Do I need to update the whole application, or I should separate my model from application so that I can easily update my model only without the application being updated? Because the current step probably you need to update maybe the whole application or something.
Thanks for that. John, if you could hear him a bit more clearly, can you rephrase the question?
Okay, so I think what he says is that suppose you already have a model deployed somewhere, and now you need an application to use the model. Do you have to bring the model inside the application, or it's okay to separate them so you have your application different from where the server is deployed?
Oh, okay. So great. That's a great question, Moses. So if you have your model deployed somewhere, it's fine to have your model running somewhere and then having your application also running somewhere. So the question now is your application able to talk to the model that has been deployed? So if the answer is yes, then there is no need to put your model directly inside your application. So you can build APIs for the model, and then you can let your application communicate with those APIs, and then it will be as though your model is within your application.
Okay, thank you.
Okay, sure.
Gilbert, many people are asking for the link to the GitHub repo. Maybe I'm thinking you could just put it in the chat.
Okay.
Maybe before we even share it ourselves, you can just put it in the chat.
Okay, sure. So GitHub.
I do not think that there are further questions. Is there anyone still who wants to ask a question, or
Yeah, so I think
if not, we can end the meeting now? Okay.
okay. So
Someone says from Francis Okoye, he says, how does AWS deployment work?
I'm sharing the. Okay, so I've shared the link to the repo, and thanks, Francis, for that. So AWS also has its own ways of deploying applications, and usually either you go with you create an EC2 instance, and then you configure it, and so it's the idea is the same. It's just the architecture and then the configuration that is different. So what you would want to do is to create an EC2 instance and then get the corresponding IP addresses and all the necessary details of your instance on AWS, and then you link them up with your Travis, and that should be it. Okay. So John, I've shared the link to the repo in the chat. Hello. Hello. Hello.
Yes, you can hear you.
Yes, I can hear you now. Yeah, so
We can hear you.
So I was saying that I have put the link to the repo in the chat. That should be it. I don't know whether John is still speaking, but I can't hear him. And can anyone hear me?
Yeah,
Okay.
I can
Yes,
hear
you
you.
can hear.
Okay, thanks, Moses and Jethro. Hello, John.
Hi, Gilbert.
Yes, it seems.
Sorry. Yes, I lost connection for a while.
Okay, great.
I
So,
think there are no further questions, right? So I think so we can bring it to a close. Thank you very much, Gilbert, for the wonderful presentation, for the link that you've also shared, because I think it's useful and everyone would like to have a look and see how they can modify and use it themselves.
sure.
And to everyone else, we thank you for joining. Gilbert, is it any message you want to give to people or there?
Yeah, so the only message that I would have to give is it's still possible. It's not a very big learning curve. My parting message is where there's a will, there's a way. So let's all keep pushing, and yes, we all get there.
Cool. Then in that case, we'll call it a day. Thank you everyone for joining. Thank you, Gilbert. And we wish you happy weekend. And we hope to see you in our next webinar. By the way, this coming Saturday, we have the first ever inter-university machine learning competition coming off, which is called the Umoja Hack Ghana, which is brought to the country in the first time in history. So if you know any students in any university in Ghana, let them be aware and sign up, compete, win some monies for themselves. And yeah, we hope to be seeing ourselves in more events like this. Thank you, everyone,
Oh, wait,
once
one
again.
more thing,
And
one more thing, sorry. And
okay,
possibly just one thing. At Superfluid Labs, we have developed a tool that automates all these process. And I'll be very much happy if you connect your businesses with either myself or to John, and we can support you with that. And that tool is called SuperML. And we can have an in-depth.
To join our YouTube channel, kindly hit on the subscribe button.
Hey aighana, like, subscribe and share.